Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, I'm going to work on simplifying radical expressions. And I'm going to do that by working through 43 different examples, basically every radical under 100 that we can go ahead and simplify. So, there's just a couple pieces that we need to work on, or at least to understand. When we're simplifying a radical expression, we're not changing the value of it. Basically, what we're doing is we're just breaking down what we call the radicand, the number under this square root symbol. And so there's a couple key components we need to understand. Obviously, all the numbers that I chose are all composite numbers, meaning they can be broken down further into a product of prime numbers or another product. And also that understanding the square root is basically asking us, what number multiplied by itself is going to give us that radicand. So what I'm going to do, I actually just noticed this. I had one written out twice. So what I'm going to do is for just kind of like the first four examples, I'm going to kind of like break it down slowly, kind of some different ways that you might have learned how to simplify a radical. And then we'll kind of start working on this doing a little bit quicker. So in the first example, though, I recognize that 64 is a square number, all right? And there's a couple different ways we can understand 64 being a square number. Well, one way is just that we know that 8 times 8 gives you 64. Or we could also write it like this, 8 squared. So I kind of compare these to like the algebra 1 compared to the algebra 2a. I'm not really, it's not really true that way, but it's just a way for me to differentiate between the two understandings of the square root. So if we have 8 times 8, obviously that is a pair of a number that multiplied by itself, right? So therefore you can see that the answer is just going to be 8. Or what I kind of think about in the algebra 2 way is that the square root and the squaring function, those are inverse operations. So therefore you can see also that we would receive 8. So whichever way kind of makes the most amount of sense to you to understand, I'll kind of work through both of them so that you kind of see it. But then for the further problems, as I mentioned, I'm going to kind of do them a little bit more in my head, or at least I'll focus more on this method in understanding them. So let's kind of work down to the first one as the prime factorization. So if you like the square root, recognizing that, when you have a number multiplied by itself, that can be taken outside of the square root. So one of the first things we learned how to do was like prime factorization. 18 is not a prime number, it's a composite number. So we can further break this down, for instance, into like 6 times 3. 6 times 3. Then we can break it down. We can break down 6 again into like 2 times 3. So you can say 2 times 3 times 3. And now you can see that I have a pair of 3s, right? 3 is being multiplied by itself. So what I can do is sometimes we'll like circle that, or we just understand that the 3s can now come outside of the radical, like here. 2 does not have a pair, so therefore the simplified form is going to be 3 times 2. So that would be our understanding of using the prime factorization, writing the number 18 as a product of its primes. And so therefore for all of these problems and for any composite number, you could always write them as a product of your primes and then find the group and find like the pairs, and then you could take those out. And that's kind of nice, especially when you do like cube root or to the 4th root, because then you're just finding, triplets of numbers or, numbers multiplied by themselves 4 times. But I don't think it's really a great use of our time because, not all, like we can always write it down as a product of your primes, but I think it's also important to recognize that using the rules of exponents, square root of 8 can be written down as a square root of 4 times 2. And sorry, not the rules of exponents, but the rules of radicals allows us, if we have the product of this, then we can just break that down into the square root of 4 times the square root of 2. Okay? Because again, if we were to multiply two radicals, as long as they have the same index, you just multiply them under that radical with the same index. Well, now I know what the square root of 4 is. 4 is a square number, just like 64. So therefore I can simplify this into 2 radical 2. And you could have done that over here as well. Instead of doing 6 and 3 is not a good way to break up that problem, but you could have broken this down into 9 times 2, which would have then give you 3 square root of 2. So you can see how it's a little bit quicker working into recognizing that method. So that's basically the method that I'm going to, when I'm doing these in my head, what I'm looking for is the largest square number that evenly divides into my radicand. Because obviously if the number is a square number, I'll just take the square root of it. Otherwise, I'm going to look for a square number that evenly divides into it, and then I can break it up into 2 radicals. So that's exactly what I'm going to do for a lot of these. I'm just going to, break them up. Obviously, you could always pick a smaller square number, but that's just going to make you need to simplify it further. And I'll kind of work on that for at least number 48 or for question number 5, because I'll do that one, one more time. All right, so let's go ahead and do 27 here. So you could write this as a product of your primes, or hopefully you guys can recognize this would be 9 times 3. Obviously, the square root of 9 can be broken down into 3, square root of 3. Okay. Now, obviously, 27 was rather simple because 9 was the only number I could think of square numbers that would divide into it. And just a real quick, let's review the square numbers. So we have obviously 1, but 1's not really going to help us out. We have 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, so all the numbers that we're doing, all the problems are going to be less than 100. So I'm going to look for all of them that are either divisible by one of these numbers. Now I look in 48, I recognize 48 is not a square number. So therefore I want to look, well, what number divides into 48? Well, not 36, not 25, maybe 16, not 9, and definitely 4. So, one of the key problems that students will do is they'll say, oh, well, let me go and just do the easy one, right? Or, let me, divide it by 2. Well, again, dividing by 2 will help you with the prime factorization. But when we're looking at using the rules of radicals, we want to only focus on square numbers. And so a lot of people see 4, they know 4 times 10 is 40. So they could say, well, I could do square root of 4 times 12, right? And yes, that works, okay? But is 4 the largest square number? And the answer is no. But let's kind of see how that would work. Or what if you did, because I recognize that 16 times 3 also works. So when I simplify this, I get a 2 radical 12. And then this one, I would get a 4 square root of 3. So you say, well, they're not the same answer, right? Well, I look at 12, I say that can be further broken down. So that's why it's just kind of helpful to go ahead and find the largest number to go and do it. Because then you don't have to keep on breaking something down. You just have 4 square root of 3, okay? All right, so that's going to be our main idea here, our main kind of thing to go through. And then I will just kind of now work on the problem. So I'll break it up into these product. I'm basically going to set up the product and then I'll do that because we have a lot of problems to get through. But hopefully at least this is the basic idea of simplifying the radicals that you can understand as we now move along. I recognize 52 is only 4 more than 42. So that's going to be multiplied by 13. And I know 13 is a prime number. So I'm just going to do 4 times 13. And that's going to be 2 square root of 13. Okay, and again, we're looking for those prime numbers, numbers that cannot be divided or broken down any further. They are their prime numbers. 99, that kind of screams out to me 9 times 11, right? And that'd be 3 square root of 11. 100 is obviously is a square number, so that's going to be 10. That's rather easy. Square root of 20, I can break down into 4 times 5, so that'd be 2 square root of 5. 36 is a square number. We love that. 50 can be broken down into, let's see here. 25 is a square number. So yeah, 25 times 2. So it'd be 5 radical 2. Let's see, this one can be broken. Could be 2 times 6, right? But 2 is not a square number. And so here's just real quick. Even though that works, but 2 is not a square number and 6 is not a square number. So that's not going to help you out, right? When you're doing this, but you got to figure out a square number that's going to divide into it. There's nothing wrong with that, only if you're going to use the prime factorization way. Like that means you now have to break down 6, which would equal 2 times 2 times 3, right? So there's nothing wrong with using that method, but you can't use it as a radical. Because a lot of people, when they're doing these, they'll see 12 and then, oh, 2 times 6. Well, yeah, but that neither of them is a square number. So I would prefer just to say, oh, that's also equal to 4 times 3, which is 2 radical 3, which I think is faster and easier than breaking it down into a product of its primes. Let's see, that's going to be, so this one is not as obvious, 96. So let's see here, that's going to be 48 times 2, right? And so 48, now 16 goes into there 3 times, 1632. So therefore, that could also write that if 16 goes in there 3 times, so that'd be 16 times 6, and that would equal that, yeah. So actually I can break this down into 16 times 6. So that'd be 4 square root of 6. So even though 6 is not a prime number, it cannot be further broken down. There's no other square number that divides into it, right? Now, again, this is the important thing that I want you to understand here is, here 96, I was trying to think like square numbers. Immediately, the only thing I did, I just divided it by 2, right? I said, oh, well, this can be broken down into 48 times 2. And I recognize 48, that evenly divides into 16 or evenly divides into that. Because initially looking at these numbers, these square numbers, I wasn't recognizing anything that really that divided into there. So therefore, I just kind of broke down the problem a little bit and just made it a little bit easier for me to see because I know that, 48 divided by 16 equaled 3. All right, but this one's obviously broken down into 16 times 2. So that's 4 square root of 2. Let's see, this one's going to be broken down into 4 times 10. 10 cannot be further broken down. 68. So that'd be 54, that'd be 60. That doesn't work. Let's see, I know 4. Let's see, that'd be 4. So if I broke down, so I know 4 times 10 equals 40. Right? Because when I double any of these numbers, I'm not seeing anything that's going to work. And then that would be 28. So that'd be 28 would be left over. So 28 divided by 4 is going to equal 7. So that looks like that's going to be 17 times 4. And that works, right? 4 times 17. Because if you think about it, 17 times 2 is 34. 34 times 2 is 68. So that'd be 2 square root of 17. These are not numbers that you commonly go ahead and see, though. Here, 98, if I divide that 2, I get 49, which I recognize is a square number. So therefore, I can say that can be broken down into 49 times 2. 49, obviously, is the square root of 7. Square root of 9 is a square number. That's 3. This can be broken down into 36 times 2, which would be 6 square root of 2. Square root of 49 is a square number. That's 7. 81 is a square number. That is 9. 76, let's see, divide that by 2. That's going to be 38. So that's not going to help us out. Let's see here. 4 would be a 36. So again, that works. So again, if I did 4 times 10, let's actually do, what was it, 16 times 5? No, that'd be 30. 6, that'd be 96. 50. Okay, 4 times 6. No, okay, that's not going to work. So let's just figure it out. So 4 times 10 is 40, right? That would be left with 36 left. So 36 divided by 4 is equal to 9. And it looks like I'm going to deal with 19. So square root of 4 times 19. Again, let's make sure that works. 2 times 19 is 38. 38 times 2 is 9. 38 times 2 would be 70, 76. 38 times 2 would be 76. So therefore, this is 2 square root of 19. 38, yes, 76. Good. And again, this is just me doing my math. This isn't like technical work. I just know that 4 times 10 is 40. That leaves me with a remainder of 36. Divide that by 4 is 9. So I could tell that it was divisible by 4. And then I figured out it would be 10 plus 9, 19 times. So it's just kind of the way my brain worked. Square root of 24. Let's see. I know that's going to be 4 times 6. So that'd be 2 square root of 6. 16 is a square number, so that's easy. Let's see here. I recognize this to be double digit. It's 4 times 11. So that's 2, 11. Here I recognize that's going to be divisible by 25. 5 square root of 3. That's a square number. That's easy. 2. Here I recognize this to be 8 times 11. Now, in this one, this is kind of important. This is interesting. So yeah, you have 8 times 11, right? That was obvious. But obviously, I can simplify this even further. Like this actually can be broken down even further than that. So yeah, I'm going to have 8 times the square root of 11. But then let's go ahead and break that down into 4 times 2 times square root of 11, which gives you 2 times the square root of 22. So we actually could have done, let's say it would have been 4, right? 4 times 2, or it would have been 8. Yeah, 4 times 22. 22. 2 times that is 11. That doesn't... Why does that not seem like that's working? That's 2, and that'd be 4. 22, 44. Yeah, okay, that works. So it'd be 4 times 22 also would have worked as well. But I recognize the 8 and 11, and then, so it's perfectly fine if you're not like finding the largest radical. If you don't find like the largest one, that's fine. Just work with what you know, and then work your way down. It's just a little bit work, but it's a lot better than me trying to figure out the largest square number that would have evenly divided into there, which would have been 4 times 22, which didn't immediately come to me. Square root of 64 is 8. I recognize that's divisible by 2, so that'd be 27, which I already know 27 can be broken down into, let's just write this down, 9 times 3 times 2. So again, same kind of idea. Like I know 27, I know I can break down 27, and therefore I get my answer 3 times radical 6. So even though 9, you could have also done this as 9 times 6, right? But that didn't come to my brain immediately, right? You also, I mean, better way would have recognized that's 9 times 6, but I didn't think about it. I just divided it by 2 and worked with there. But you would have gotten the exact same answer, and this would have been faster if it would have came to you. For me, it didn't. That one's going to be 5. Square root of 92. Again, you know, this is not something that is immediately going to come to me, so therefore I'm going to divide this here in by 2. So I'm going to divide that by 46. Right, that becomes 92. And then I see what is divisible here by there. I'm not recognizing 36. Let's see here. 3 is not. 92. So again, let's try to go through this. 49 times 2 is going to be 98, so that's not going to work. So I could do 36. 72, if I added another 36, that's not going to work. So it's not 36, not 25. Let's do 16. That'd be another number that's possible. So 16, let's see, times 6, and that would be that's going to be a 90. No, that'd be a 96. So that's not going to work. Let's see here. And 4, that would be a 40. That'd be a 52. Oh, that does work. Okay, so let's break that down. 46 times 2. And then we could break that down into 43 times 2 times 2. So in this case, I'm sorry, not 43, 23. Yeah, this one is not as easy to come through, right? But I can use the linear factorization. I don't know why I didn't do that, right? I could break down 92 as the 46 times 2, and I could break that down into 23 times 2 times 2. Like the square numbers don't immediately come to me. However, I can recognize that, and I say, oh, that's going to be 2 times the square root of 23. Or 4 times square root of 23, if that would have came to you, which would have been awesome. But remember, that's how we can use, break down that linear factorization to help us out. Here, I'm recognizing 9 times 5. That would be 3 square root of 5. Here, I recognize 8 times 10, or you could do, let's see, 4 times 20, or you could do 16 times 5, I believe is also recognizing to me. So 16 times 5, because I recognize when I do, 8 times 10, I know that can be simplified, right? Which is also the same thing as, 4 times 20. So when I write those out, I recognize, oh, I can simplify, the 8 and I can simplify the 20. So let's go ahead and see if there's a larger square number that will divide into it. Obviously, I get 16 times 5, 50, that's work. So therefore the answer is 4 square root of 5. Here I recognize that's going to be a 9 times 7. So that's 3 square root of 7. Here I recognize 4 goes into that. So that'd be 4 times 7. 81 is a square number, so that's going to be 9. 4 is a square number, that's going to be 2. Let's see, 60. I know 4 goes into there, right? Because 4 times 10 is 10, and that'd be 4 times 15. Right? So 30 times 2 is 30 times 2, so yeah, that's going to be 2 square root of 15. 84. Let's see here. That can be broken down. Let's break this one down. That's going to be 42 times 2. Let's break this down again. 21 times 2 times 2. So therefore, you can see this answer is 2 square root of 21. I can't break down 21 any further. Or you could have gotten 4 times 21 if you would have recognized that. Square root of 36, square numbers, so that's going to be 6. 56, let's see, 7 times 8, right, is 56. So that means we could also do, let's just break it out to 7 times 8. I know that, 8 times 7 equals that. I can break that down into 4 times 2 times 7. So that'd be 2 square root of 14. So also would have been 4 times 14 also would have worked. So if you would have recognized that 4 times 14, you would have got the exact same answer. And then last but not least here is 90. I recognize this to be a 9 times 10, which is 3 square root of 10. So there you go, ladies and gentlemen. I worked through 43 examples to help you out. Basically anything that can be simplified as a square root expression under 100. And you can see I worked through many different ways. I looked at doing the prime factorization, using the rules of radicals for you guys to kind of see with those square numbers. And I really think just going through this and practicing these and kind of seeing and making sure that you are, familiar with not only your square numbers, but how to further break down problems is going to help you keep simplified problems up in your future. So I hope this video helped, and I look forward to seeing you guys on the next videos. Cheers.